Hello everyone, welcome to Proof of Concept channel. As part of POC today we are going to see wine class prediction using XGBoost classifier. The objective of this proof of concept is to predict the class of wine using the XGBoost algorithm. So we are going to use the sklearn load wine dataset for this model. The data is the result of a chemical analysis of wines grown in the same region in Italy by 3 different cultivators. There are 13 different measurements, so we have 13 attributes. Based on that, our model is going to predict and tell us which classes they are belonging to. That is the objective of this proof of concept. Following are the steps involved in this process: load required libraries, import dataset, exploratory data analysis, data pre-processing, model building using XGBoost classifier, model prediction, feature importance, and a summary. Let's start one by one. Before that, let me showcase how the data look like. Let's go to Google and type sklearn load wine. Yeah, we have this link. So just to click this link, this is our dataset. We are going to use sklearn dataset load wine. Let me click the user guide here. Yeah. So we have number of instance 178, which means we have total number of records 178 total number of records. Number of attributes 13. We have 13 independent variables. These are all the attribute informations. We have alcohol, malic acid, ash, and then color intensity, proline. These are all the attribute details. And this is our target variable class. So we have 3 types of class 0, class 1, and class 2. If you see here, the data is the result of chemical analysis of wine grown in the same region in Italy by 3 different cultivators. There are 13 different measurements. Based on that, our model is going to predict which class they are. So these are all the attribute details as the input to our model, and our model is going to tell us, so based on these attributes, which class they are belonging to. That is the intention of this model prediction. Let's go back to our model building. Right now we are in step 1. Step 1, load required libraries. We need the data from sklearn. So this is the step for loading the data, load wine. And we are using XGBoost classifier here. So that's taken from XGBoost and XGBoost classifier. Let me quickly run this. Okay. So in step 2, we are going to load the wine. So we have wine variable and we are loading the wine. And in the data frame, I'm going to show with all our attribute information as well as the target variable here. So this is how our attribute details as well as the data look like. So we have all 13 independent variables. Here if you see alcohol, malic acid, all the attribute details, and our target is this one, the last column. So the last column is showing the 0, which means our target variable 0 for this, all these attributes. So this is the input data we are going to feed to our model. Based on that, our model is going to predict and tell us what class they are belongs to, whether it's a class 0, class 1, or it's a class 2. So in this step, I'm just describing the data. So the same details. So we have all the attribute details and number of classes we have. All those details are here. Let's quickly check what are all our classes are. We already know that we have 3 classes: class 0, class 1, and class 2. These are all the 3 classes we have. In step 3, we have exploratory data analysis. We are going to see the shape of the data frame. So we have 178 records and 14 columns, including the target columns. We have 14 columns. So here in this step, we are seeing that if we have any null values available, check for null values. We don't have any null values, all are 0. And this is the alternative approach, but checking the null values. So in this step we are going to see any missing values in between any of the variables. So that's what we are checking here. We are taking the value counts of every attributes. Let me quickly run this. So here if you see, everywhere we are seeing 178, which means no null values, every values are same. Since this is the toy dataset, sklearn providing the toy datasets, we don't need any null value imputations or anything, because this data is already available for us to do some practice. So the describe, this will tell us the count of values as well as the median and mean values. So if you see here, the mean and median value of the ash, we have the mean and median value of ash is 2.3. Similarly, the 75% of the data have alcohol percentage of 13.6, that we can see that 75% here. Yeah. Similarly, for the median value of the proline is 278. If you see the proline here, the median value is 278. Yeah, those kind of the analysis we can do as part of this one. So we can see the mean and the median value and count, minimum value, maximum value, all those analysis we can do as part of this one. This is just an info, the data frame.info. So this will provide us what kind of data types we have. If you see here, all our attributes, the 13 attributes that we have, all are float data type, and the target is integer data type. That's the reason we see the target values right now 0, 1, 2. It's already converted into numerical format. Now we are going to plot using the SNS plot. Let me quickly run this. This might take some time to complete. It's done right now. So using this plot, we can see a lot of the positive correlations. Let me start here. If you see the alcohol, we can see the proline and alcohol, there is a positive correlation, and the color intensify, we have it a positive correlation, and similarly for the proline we have a positive correlation. So there are, like, using this graph we can see we have any correlations between our independent variables. So the positive or negative correlations between the data sets you can easily identify using this graph. So the next step is we are going to perform some univariate analysis. So I'm going to plot couple of attributes in the bar plot, so that we know like what is the count of it, and what is the minimum value and the maximum value, all those things. Let me quickly run this. So see here, right now the alcohol distribution, this plot. So here we can see the count, like every category, every measurements, we can see the count of it. So the maximum value is around 33. Those kind of analysis we can do using the bar plots. Similarly for malic acid as well. So we can see the count of it. And here we are seeing the proline and then color intensity. So if you see here, the count of proline 600 is coming as maximum, more than 45 records that we have with the 600, and the remaining count as well. So addition to that, we have this box plot. The box plot especially for visualizing the distribution. So here we have the line, this is the median line, and we can able to see that whether it's a positively skewed or negative skewed. So let me quickly run, this is the syntax to run the box plot. Yeah. So right now if you see here, this is for hue. So the hue is normally distributed, so we are not seeing any positive or negative skew here. However, if you see the proline, the median line is towards right side, which is a positive skew. In case if the median line is towards left side, then it's a negative skew for proline. But according to this picture, proline is a positive skew. The next step is we are going to see it in the heat map. I have given few attribute details, and then we are just seeing the heat map. So the heat map, we can able to see all the correlations and the positive and the negative. So if you see here the proline, we have the positive correlations. Similarly, color intensity, we have a positive correlations. And if in case if we have any negative correlations also, we can see using that heat map. I haven't put all the attributes, but you can validate with all attributes. You can provide all 13 attributes here, and then see how this heat map look like. Okay. So right now we are in step 4. Here we are starting the data processing. So I'm separating the target variable and other variables into x and y. So if you see here, x, we are going to keep all our independent variables, and y is the target variable. The next step, we are splitting the data 70-30 for the test and train purpose. So this function for splitting the data, train and test is split, and we can see the shape of it. So this will give us the shape. So if you see here, the train shape 124 and 13 attributes and 124 row records, and testing we have a 54 and 13. That's the data. So right now we are in step 5. So we are going to build a model. We are going to use the XGBoost classifier. Before going to the further steps, let me explain quickly what is XGBoost is. To know XGBoost, we should know like what is gradient boosting is, because XGBoost is derived from gradient boosting. Gradient boosting is a supervised machine learning algorithm. So as we see our example, so our model, we giving the input attributes as well as the target variables. So we should have the input as well as the output for the supervised machine learning algorithm. Also, the term gradient boosting comes from the idea of improving a single weak model by combining it with the number of other weak models in order to generate the collectively strong model. So that is the concept behind gradient boosting. Now let's see what is XGBoost. XGBoost is one of the most popular variant of gradient boosting. XGBoost stands for Extreme Gradient Boosting Algorithm. It is scalable distributed gradient boosting decision tree. XGBoost provide excellent execution speed and model performance. So these are all the reasons in today's world a lot of production applications they build using XGBoost. We are here right now, the step 5 model building. So I'm using XGBoost classifier and then fitting the training data in this step. So our model is ready right now. If you see here, this is our model. Our model is ready for the prediction. I'm trying to predict using the test data xgboost.predict of xtest. We got the predictions. Let's validate what is the accuracy from our model. We got 98%, which is very good. So normally when you build XGBoost classifier, when you build with XGBoost, you will be getting like very good score. This like that's what like a lot of production applications they are using it XGBoost classifier right now. So we got 98%, which is quite good. So our model is telling that it can predict 98 values correctly out of 100 values. So that is what we got, the 98%. Let's do the prediction. So let's see what are all the values we predicted. So these are all the classes we predicted, but we can't understand really what it is now right now. But the next step, I'll put it in the data frame and show what is the observed wine classes as well as the predicted wine class. So this is the step for that. So here we can see what is our input and what is the model output as well. Yeah. So here if you see this observed wine class, this is the input that we feed into the model, and the predicted wine class, this is the output. So we have all 13 attributes. Based on all these attributes, the chemical analysis, our model is predicted the type of the class. So here if you see, the observed class is class 2 and the predicted also class 2. So all these classes predicted correctly. So if you see class 2, class 1, class 0, all these predictions are same as like what we expected. We don't see any errors, but according to our model, it's a 98% of accuracy. We may see some error in some of the records, but not here. Here every values are correct. Every predictions are correct. Step 7 is the feature importance. So this is an additional step we are going to see. Feature importance is a techniques that is going to tell us contribution score of every attributes towards the model building. This would help us to find out which features contributed more towards the model building, so that we will get rid of all the unwanted features during the model building. So if you see here the prolin, this is contributed more to the model because it's a very high score, and color intensity and other attribute details, even alcohol, all other details. So when you come down, some of the features they contributed very less. Like if you see here, these malic acids, they got a very less score, and other attributes as well. So which means what they are saying is, maybe if you think about like reducing the dimensionality, we can reduce these attributes, because now we know that these attributes are contributed very less to our model comparing to other attributes. We are in step 8, the summary. As part of this POC concept, we have achieved the prediction of the wine classes, as well as we loaded the sklearn dataset, and we did some EDA exploratory data analysis, and we split the data into test and train, and we built a XGBoost model, and we did a prediction, and we got a prediction result as well. Thank you so much for watching. I have given all these commands and the notebook link in the description. You can utilize this. You don't need to install any software or any configuration required. You can use Google Colab and execute all these commands into Colab. And let me know you can able to successfully reproduce this XGBoost model, and you can build a model in the comments below.